Yeah, Contessa, good evening from a frigid Dallas. And the concern right now are these rolling outages, these periodic blackouts that have been going into effect since early this morning. That leaves up to 2 million Texans without guaranteed warmth for what looks to be an incredibly frigid night ahead. As you mentioned, the entire state, for the first time in weather history, under that winter storm warning. We also had portions in West Texas that were under a blizzard warning. We reported early this morning 7 degrees in parts of Dallas and other parts of the state. And right now we're looking at an evening that could get even colder, breaking historic temperature records that have been in place now for decades.
In the past few weeks, US multinational Microsoft has been experimenting in Scotland.
Project Natick is a radical approach to how we deploy data centers. So we're taking green data centers, deploying in the ocean. The overall goal here is deploy data centers at scale anywhere in the world from decision to power on within 90 days.
In layman's terms, Microsoft are experimenting with North Sea water cooling of electronic storage for all your cloud computing, from personal music and emails to military warfare information. But the company, with a market cap predicted to soon equal the combined GDPs of Israel and Saudi Arabia, is not just associated with environmental solutions to storing your emails. Its founder, Bill Gates, is also interested in geoengineering in the face of climate change. And it's something that appears to have the blessing of the Intergovernmental Panel on climate change.
Climate research community is largely and understandably focused on the serious risks of unmitigated climate change, of temperatures going above 2 degrees, and how to balance those risks against the potential risks associated with deploying these technologies.
But exactly what are these technologies that are being debated?
Solar geoengineering specifically is the idea of introducing a substance into the stratosphere that will cool down the planet by reflecting back sunlight. The same idea as wearing a white shirt in summer. The white shirt reflects sunlight back. You don't feel as hot as if you wear a black shirt.
One private company researching just that is Carbon Engineering. It's funded by Bill Gates and Canadian tar sands tycoon Murray Edwards. It's looking into firing aerosols into the atmosphere to block out sunshine. And here's the research being advocated by the CIA when it was led by Barack Obama's chosen boss, whose security clearance was revoked by Donald Trump in August.
Another example is the array of technologies, often referred to collectively as geoengineering, that potentially could help reverse the warming effects of global climate change. One that has gained my personal attention is stratospheric aerosol injection, or SAI, a method of seeding the stratosphere with particles that can help reflect the sun's heat in much the same way that volcanic eruptions do.
The record number of fires burning across Brazil's Amazon rainforest has prompted renewed global outcry over climate change. And big spending. $5 million from Leonardo DiCaprio, £10 million from the UK. Meanwhile, Bill Gates is backing the first high-altitude experiment of one radical climate change solution, creating a massive chemical cloud that could cool the Earth. It's called solar geoengineering, and it's highly controversial.
How long will it be that countries keep experiencing these climate impacts before someone gets desperate and says, hey, we need to cool the planet with solar geoengineering?
It would look something like this. Thousands of planes would fly very high and use nozzles to inject millions of tons of light-reflecting particles into the stratosphere. It would create a thin chemical cloud of those particles around the whole planet, blocking some sunlight from reaching the surface. It would mimic a giant volcanic eruption, which we know cools the Earth. Back in 1991, Mount Pinatubo erupted in the Philippines. It was the largest eruption to affect a densely populated area, creating avalanches and giant mud flows that left more than 700 dead and 30,000 homeless. It also spewed a cloud of 20 million tons of sulfur dioxide particles into the stratosphere. That chemical cloud was hundreds of miles across and reflected about 2% of sunlight back to space. And in 1992, the Earth was cooler than in 1991.
That is part of the mechanism, but you do this in a controlled way.
Modelling studies have found that it could reduce the intensity of heat waves, for instance. Apparently it could reduce the rate of sea level rise. It could reduce the intensity of tropical storms.
But it also comes with significant risks and uncertainties.
Things like mass famine, mass flooding, drought, of kinds that will affect very large populations.
It could weaken monsoons in India, China, and Africa enough to affect crops. It could eradicate blue sky.
You start increasing the amount of diffuse light and you have less direct light, which is the same thing as saying it looks hazy and white.
And if the global community decides it should stop?
So you stop injecting it, and after a year, the cloud is gone, and you get this rapid warming at a rate much faster than you would get if we had done nothing. If you've taken out the greenhouse gases that are adding to the warming, then the temperature won't go up, it'll stay what it is. So if we don't stop emitting greenhouse gases into the atmosphere, we don't try as hard as we can to do that, then there's no point in doing solar geoengineering.
A 2016 opinion poll conducted by the Harvard group doing solar geoengineering research found that 67% of subjects support its use. One reason this technology is appealing, it's cheap. One study estimates it would cost an average of $2.25 billion globally every year for the first 15 years of deployment. Compare that to the $500 billion the U.S. government estimates it will cost just the U.S. by 2100 if no action is taken against climate change. Or the $1.6 to $3.8 trillion projected global spending by 2050 on low-carbon energy production. You can also compare it to direct air carbon capturing, another climate change solution backed by Bill Gates and by big oil. It involves sucking billions of tons of carbon out of the air. And at $100 to $200 a ton, it could be big business. Solar geoengineering, on the other hand, is so cheap that nobody currently stands to make money from the process.
But just because a solution is cheap doesn't make it a good one. It's cheap and dangerous.
It doesn't require a lot of materials. It doesn't require a big innovation. It basically affects the whole planet with one project. So that is not necessarily a situation that has a lot of profit opportunity, right? Because there's not going to be a lot of different people that can do it and compete in a marketplace.
Bill Gates is among a dozen individual donors and 14 foundations backing the first stratospheric solar geoengineering experiment out of Harvard. It's called Stratospheric Controlled Perturbation Experiment, or SCOPEX. A high-altitude balloon will lift instruments about 20 kilometers into the stratosphere, where it will release less than 2 kilograms of different naturally occurring chemicals, like calcium carbonate and sulfates, and then measure the change in atmospheric chemistry and light scattering. The Harvard group that runs SCOPEX and other experiments has raised more than $16 million, more than double any other solar geoengineering effort. And annual global funding has gone up from $1 million in 2008 to $8 million in 2018, with the majority of that funding coming from the U.S. The first phase of SCOPEX will cost around $3 million, with much more needed for wider research on solar geoengineering. To this point, stratosphere injections have only been tested with climate modeling. In the UK, a government-funded solar radiation management test called SPICE was cancelled in 2012 because of issues with patents.
And we're not trying to develop any technology that is patented or where we want to make money with this later on.
A study last year found that no existing aircraft can inject the stratosphere at a high enough altitude, but developing a new high-altitude tanker would not be technologically difficult or prohibitively expensive. Nozzles still need to be designed that can continuously blast out trillions of particles, and scientists still need to decide what chemicals those particles should be made of. But unlike cloud brightening, which is another solar reflection technique, the tech needed for stratospheric injections is not far off.
The technology is not the main thing that's holding this back. The main thing that's holding it back is the uncertainty about what the exact effects would be and the positives and negatives of its effects, and the governance and decision-making process for implementing it.
Other radical attempts to control climate change have been tested in the past, like when one California businessman dumped 100 tons of iron dust in the Pacific to spawn the growth of carbon-absorbing plankton. But unlike small, sometimes rogue experiments, planet-wide solar geoengineering will require buy-in from the international community.
In our simulations we found China got warmer and drier relative to the past when you stabilized global temperature, and India was now cooler and wetter. So you can see there how, international relations around using this technology could become complicated.
I mean, we can't even decide on what to do about emissions of greenhouse gases, and so how are we going to decide on setting the planetary thermostat?
There's the real concern that we won't be able to reach agreement, we being the entire planet. And so there's the prospect that countries just go ahead and do solar geoengineering, and that causes disagreement, conflict, tension, even possibly war.
3 years ago, the international community did come together when almost 200 countries signed the Paris Agreement on climate change, agreeing to limit global temperature rise to less than 2 degrees Celsius. Since then, President Trump has stated his intent to withdraw from the agreement.
The Paris Climate Accord is simply the latest example of Washington entering into an agreement that disadvantages the United States.
And global emissions are not being reduced fast enough to reach these goals.
We know what we should be doing. What we should be doing is reducing carbon emissions. So we're creating a moral hazard. We are providing an out for you where you can say, well, I'm going to fix this technologically instead of doing the ethically right thing to do.
It's way too early to give up on much more ethical approaches to climate change. Right. If future generations were literally in the room to question us on our dubious arguments, we wouldn't get far with some of the kinds of arguments we're trying to offer for neglecting conventional climate policy and going down this path.
For now, the failure to rapidly reduce emissions has prompted more exploration of alternative solutions like carbon dioxide removal and solar geoengineering. But scientists warn we will still need to reduce emissions too.
If we're not cutting CO2 emissions at the same time, from my perspective, there's little point in doing this because you would have to start using ever-increasing amounts.
No responsible scientist says that it's a silver bullet. All the responsible scientists say this is something that we deploy if we had to, alongside all the other stuff that we already have to do.
The U.S. Academies of Sciences is holding a series of meetings to study solar geoengineering, including one at Stanford this month. The committee will issue a report next year with recommendations for how, or if, solar geoengineering research should continue. Some scientists say the research is necessary in order to arm future generations with the ability to enact this backup plan, even though it seems nearly impossible now.
We ought to start working on this solar climate engineering problem right now with as much urgency as we can, so that if we want to deploy it in a decade or so, we understand what we have to do.
This is a real moral horror, especially in a situation where we're not doing all the things that we could be doing to minimize the risks of climate catastrophe now.
But experts do agree that more public awareness is needed around solar geoengineering, because within a couple decades, for better or worse, it could be part of the solution, helping return the planet to pre-industrial temperatures.
Modelling evidence gathered over the last decade has pretty consistently found that a moderate amount of solar geoengineering could significantly reduce many of the impacts of climate change. But it can't be a solution because it doesn't return the climate system back to how it was. It doesn't do anything about things like ocean acidification. So whatever happens, we've got to cut our CO2 to zero. So right now, we need more research to understand this better and a broader conversation so that all of the world's nations have a seat at the table when this is discussed.
There are overlaps between the challenge of fighting the pandemic and the challenge of fighting climate change. What steps can government take to address them both at the same time?
Well, the idea that you count on government to see problems out in the future and to really look at the science and understand what will work, what won't work. The pandemic illustrates that government didn't look out for us despite the warnings that were out there. Climate fits that same paradigm. Sadly, in the case of climate, as it gets worse and worse towards the end of the century, there isn't anything like a vaccine that you can spend, tens of billions on, and then boom, your mistakes, although they're horrific, you can bring it to a close. Climate change is much harder, and the damage that will be done every year will be greater than what we've seen during this pandemic. So, I hope it's a wake-up call to think, okay, what else are we being warned about? Does it take, what percentage of government resources would that take? And holding people to account that even things that take a long time, we have to get started now on.
One of the things common to both the pandemic and to climate change is a growing mistrust of science. Where will this country end up, Bill, if voters don't believe what scientific data show and what scientific models indicate?
Well, I think it's more who do they trust? Science, no one knows all of science. I'm a perennial student and the percentage I know is very, very small. But there is this way of picking really good people, having really open debates about what's known, what's not known, trying different things out. There's an approach that, science teaches us that lets us find what those right investments should be. Will this vaccine work? Will this bridge fall down? All sorts of things that really, really count that you don't expect the population themselves to know, but you should pick somebody who believes in experts and, can admit mistakes and is willing to come up with a long-term plan and just saying, hey, we're a selfish country. Well, for some things that works, but for some things without global cooperation, it's a huge problem for this country. I think it's more to do with engaging smart approaches than, the public knowing a lot of science themselves.
When you describe those desirable attributes, do you have anyone in mind?
Well, somebody who's proven that they have wisdom and that they pick very strong people and they'll build a team approach. That's what we do when we give out money as a foundation, and that, we have fortunately a lot of success using that approach.
Okay, so we talked about this last week, and now we're going to do a deep dive with Davo. Dubai is making it rain in a sweltering desert by zapping clouds with electricity using drones.
Fascinating, isn't it?
So much to ask, but let's take it, and then we'll do a few questions.
Before we talk about what's happening in Dubai, let's talk about cloud seeding in general, because a lot of people, I don't think, understand what cloud seeding is. And this has been going on for decades, by the way. This is not something that's brand new. But traditionally, what cloud seeding is, it involves using aircraft or drones or even some cannons to push silver iodide up high into the clouds. Why silver iodide? Because that has the same crystallized structure as ice. So once it gets up into the clouds, it starts to accumulate ice on it and these large raindrops, which helps, especially in a cloud mass that's not really going to rain. It helps to bring rain and especially snow down.
So it works.
It does work. Marginally. But the problem with silver iodide through the years has been this, is that they feel it could be harmful to aquatic life. Okay. So over in Dubai, which is what you're seeing here, they took it a different step, and what they basically did, they had a fleet of drones that flew up into cloud cover, and they used electrical charges to force water droplets to combine into larger ones.
So not silver, not cloud seeding as we know.
No, they're not using the traditional silver iodide, which takes out the environmental aspect of that, okay? So they're using just electricity to create larger raindrops. Why larger raindrops? Because in Dubai, they only average about 4 inches of rain per year, as most of the rain that falls out of the clouds evaporates because it's so hot, it's so dry, and the water molecules are so tiny. So they're trying to stimulate by using electricity these droplets to be larger, hence they can make it to the ground. Now, I will tell you that the jury is still kind of out a bit on whether or not this was a fluke, whether this is something that can work long term. So they need to continue with these drones, and they're going to continue to do this. Yes, Mr. Rhodes?
So, assuming it works and it wasn't a fluke, Why not use this out in the western U.S. where all these wildfires are and the drought is going on? Could this not help us
That's
here?
a fantastic question, and they've been trying. This is stuff that, first of all, it's very expensive too. You're talking about millions and millions of dollars, which is fine when you're trying to alleviate a drought.
Sure.
It cannot work with wildfires. Here's the thing: you can't just throw silver iodide or electricity into a clear sky and it rains. It doesn't work that way. You have to have the right cloud structure, the right cloud height. They have to be tall, getting up well into the freezing layers. Then you can try to stimulate that process. And they've done that out west. During the winter time when they get days and days of cloud cover, they've done that, and they've noticed they've been able to increase the snowfall pack 5 to 15%.
Okay.
But the area and the weather, Russell, around wildfires is not conducive to that type of cloud cover, so you can't do it. In other words, we need to treat the drought, which will then alleviate the wildfires. Does that make sense?
Yes.
And that's the way it has to go. 5 to 15% increase in precipitation out west due to this. It's a start.
Okay.
And it's a good start, especially over in Dubai for those folks who are just trying to generate more rainfall. Now, on the opposite side about, oh, we're done, we don't have any more time.
Another time, we'll pick it up another time.
The UAE is one of the driest countries on Earth, with an annual rainfall of roughly 120 millimeters. As a result, it has to get creative when it comes to finding solutions for water. In the early 2000s, the UAE started performing regular cloud seeding operations. Cloud seeding is the process of increasing the amount of rain produced from clouds.
Some of these clouds, by nature, sometimes it rains, for example, only 40 to 50% of its rain that processed in the cloud that comes as rainfall. So by these operations, we try to increase this amount by, for example, from 15 to 30%.
So how does it work? It starts here, inside the National Center of Meteorology, where a team is constantly monitoring forecasts, looking for potential clouds to seed. The operations only work with cumulus clouds, which are vertical in shape.
Research 5 operation, can you read me?
Once they spot a cloud, they radio the pilots, who then take to the air armed with hydroscopic flares filled with a mixture of potassium chloride, sodium chloride, magnesium, and other materials. It's essentially salt. When the plane reaches the right clouds, the pilots release the flares.
These salts basically attracts the moisture and try to make it condense. So these particles becomes nuclei of condensation, and then when these droplets condense, and then they hit each other, and then they form a bigger droplet that the air cannot hold it any longer in the air, so it forms as rain.
In 2017, the UAE performed 242 cloud seeding operations. The government is confident the operations are increasing the amount of rainfall, but it's difficult to gauge.
Until now, there is no way that you can measure the success rate for each individual cloud. There are no two clouds are the same, and you don't know, for example, before actually you see the cloud, is it going to rain by itself or not, and by how much?
The country has also invested in rain research, offering millions of dollars in grant money to innovative researchers and projects.
Cloud seeding is already used in China and Thailand to tackle air pollution. Tests will be conducted on whether the technology can be implemented in the battle against fine dust here in the nation. Hong Yu sheds light on the government's latest measure to help clear the air.
South Korea is launching a pilot program on Friday that aims to create artificial rain to try and help reduce fine dust. The Korea Meteorological Administration and the Ministry of Environment explained that planes will fly over the western coastline of Gyeonggi-do Province, spraying clouds with silver iodide that causes water droplets to form. China, with an advanced technology for creating artificial rain, found out that more than 10 millimeters of rainfall is needed over a 3-hour period to see a 10% reduction of ultra-fine dust density. This means that the amount of rain that can be created is what matters in an artificial rain test. But China, even with its artificial rain-producing missiles and tanks, is struggling to increase precipitation. Thailand, on the other hand, sprayed 3,000 liters of water into the air, but failed to see any effect. Then they moved to using drones to make rain. For Korea, the days that such tests can be carried out are rare, because when fine dust settles over the country, there are no rain clouds as the atmosphere is under the influence of an anticyclone. so it's important to customize the technology for Korea's climatic properties. On Friday, the density of fine dust will be measured after cloud seeding starts producing rain. The result of the first test will be announced on Saturday. Hong Yu, Arirang News.
We're here in Santa Barbara County, home to one of the longest-running cloud seeding operations in the country. We've got some ground-based cloud seeding equipment right here, and we're going to get to hear all about how it works and see it in action. Let's check it out. Cloud seeding is the most common type of weather modification, and it has many different techniques and applications. Today, it's mostly used to increase rain and snowfall, reduce the size of hail, and reduce fog at airports.
Traditionally, cloud seeding has been done from the air. So airplanes have had racks on them where these same flares are positioned on the airplane, and the airplane flies into the storm. So in order to reduce the cost to the client and reduce our carbon footprint, we've been able to station these on the ground. Now we can do this in places where weather permits.
Behind a barbed wire fence designed to keep away curious cattle, the cloud seeding gear awaits the right kind of weather.
So these are referred to as AHOGs. That stands for Automated High Output Ground Seeding Systems. We've got three primary components of our equipment here. The first is the control module that you see behind me. Then we have our actual cloud seeding flares. The cameras for security. It also helps us observe weather conditions in real time and make sure that all of the equipment is operating correctly during a storm. Inside these canisters are the flares with the seeding agents. The canisters are used as spark arresters, so they prevent sparks from reaching the ground. So if we pull off the spark arrestor, you can see the flare inside. The ignition of the flares are controlled from the control module that's behind us. So the white triangle there is a cell service modem, and then the solar panel keeps us powered. Inside we have a battery and then a control board. So the control board interacts with the software. We're linked or synced with the software in Utah currently, and that allows us to fire or ignite any of the flares from that remote location.
Because of the lack of clouds and proper wind conditions, today is not a good day for cloud seeding at all. But Garrett and his team are going to light a flare for us anyway, so we can show you how it works. There's just one small problem. The battery in the control module died shortly before we arrived, but it's nothing a little jump start can't fix. After a little juice from Garrett's truck, it's time to set off the flare.
The primary seeding agent in this is silver iodide. Silver iodide is a simple compound. It's polar in nature like water, so there's chemical properties that help attract water molecules to silver iodide. It's also structured molecularly similar to ice. So it helps generate or helps spawn the generation of ice buildup, and then that becomes a hailstone or a snowflake that falls here primarily as rain. So one flare like this has billions and billions of potential sites for that water to congregate around. We'll launch them in sequences. We watch the radar to see when bands of the highest concentration of liquid water are passing above us in the clouds, and we try to target those high concentration pockets in the storm systems. We'll launch between 3 and 20 flares for a typical storm. Once the flare is lit, it takes a little bit of time to carry up into the clouds, and once it's up at the proper elevation, it'll take about 20 minutes to instigate the rain or the snow process. So overall, you're probably looking at about 40 to 45 minutes before you're seeing the maximum result. And that's why we're stationed miles away from our target area. So we have very specific targets that drain directly into major water basins, and we time these events to correlate with rain above those intended targets. One of the biggest questions or most common questions that we receive relates to the safety of silver iodide. Silver is biologically inert, so it will not interact in a negative fashion with plant or animal life. Iodine is actually a critical building block of a number of hormones in animals, so it is safe as well. In fact, if you look at table salt or baby formula, you'll see iodine in its molecular form as an additive in those commonly consumed substances.
But what about other potential adverse effects? Could cloud seeding affect communities outside the targeted areas?
Sometimes there is a concern about robbing Peter to pay Paul. So are we benefiting California at the expense of Nevada? And the truth is that storm systems, when they move over off the coastline, only about 10% of that moisture is going to fall in the form of precip. And we're looking at increasing that to about 11% because we have about a 10% increase in the natural storm's productivity. So going from 10% to 11% in California has an insignificant impact on the amount of precip that will still be available in Nevada or Utah.
Built into the program are kind of checks to make sure that we don't come across anything negative. When there are high-intensity storms, we won't seed. If the reservoirs are full, we won't seed. If the rivers are flowing a lot, maybe near flood capacity, we won't seed.
We hope that the conditions that exist right now will turn around and that we will not face the severity of droughts that we're facing, particularly this year. But a number of scientific articles are suggesting otherwise. And as we look into the future, we need to again consider conservation first. So the ability for us is to conserve how we use water and the ways that we store the water. And then layer on that efforts like weather modification and cloud seeding to help increase the rainfall that we do receive. It's very important that we take advantage of every opportunity we have to generate water in a sustainable way.
Anybody who's interested in learning more about cloud seeding, I've got links to scientific studies and official reports down in the description.
I don't know if this is true or not, that some scientists are trying to figure out a way to block the sun to try to slow down global warming.
Yeah, it's a measure of the feeling of desperation that some of them feel.
Are they really thinking they could do that?
Well, some of them are seriously proposing, and I think it's completely nuts.
Yeah.
You put another kind of pollution, sulfur dioxide, up to orbit, cover the atmosphere. The sky won't be really blue in the way it is now anymore, but it would block out some of the sun's heat so that we wouldn't have to take the difficult steps to stop spewing all this global warming pollution into the atmosphere. And of course, there are a lot of problems with what they're proposing.
You could actually spray sulfuric acid in the stratosphere 20 kilometers over our head and use that to stop the planet warming up in a ugly tech fix.
You can spray something into the atmosphere to change.
Spray pollution into the atmosphere to stop it warming.
How do you do this?
You'd start with a fleet of modified business jets and say 20,000 tons of sulfuric acid into the stratosphere every year. And each year you have to put a little more. And this doesn't, in the long run, mean that you can forget about cutting emissions. We will need to rein in emissions.
We'll get to it eventually. But in the meantime, we're shrouding the earth in sulfuric acid.
So people are terrified about talking about this because they're scared that it will prevent us cutting emissions.
Right, and also that it's sulfuric acid.
We put 50 million tons of sulfuric acid in the air now as pollution, and it kills 1 million people a year worldwide.
Okay, but it'll be better if we put more in.
We're talking about 1% of that.
1% more, we're just killing 10,000 more people.
You can do math.
What happens to the sulfuric acid after it's sprayed? Does it just stay up there?
No, it rains down, but it's a tiny addition to what we're already doing.
Is there any possible way this could come back to bite us in the end?
It actually turns out to be an old idea. This was known since President Johnson.
You ever look at those planes up there? They have contrails behind them. Maybe all those planes with the contrails, maybe they're actually spraying chemicals into the atmosphere right now and Uncle Sam isn't telling us.
Seems extremely unlikely.
That the United States is not telling something to its citizens? That seems extremely likely to me. Read the newspaper. I think they might have your idea already.
The little picture is from a nanofabrication study, which shows you can make very high quality, and do this in just a jet in a very simple way, make high quality aluminum particles just by spraying aluminum vapor out, which oxidizes. So it's certainly in principle possible to do that, and there's a big literature that's already looked at that. And you could do that by either building new versions of these aircraft or even re-engineering existing aircraft. So there's some ideas of that. So you go to an engineering firm and you want this done. They don't say this is hard or unusual. They say, okay, yes, we could do it. Aerosol geoengineering looks like it is so cheap that the cost is basically not going to be an issue. That means that implementation decisions will be risk-to-risk decisions. the risk of doing it against the risk of not doing it. And it makes the problem of how we govern it fundamentally harder and different and novel. So I've told you that it's cheap to deliver materials to the stratosphere, and I'm convinced that's true. I don't think that will change. But I think the more we do research, the less easy this will look, the more complicated the environmental effects will look. And that's a good thing, because right now it looks too easy. So I think that if we do more research, we're likely to find out that it's harder and more complicated than we thought, and that the side effects are harder to manage, and that's a healthy outcome that will make it easier to do the management. Of course, the opposite reaction is possible. It's an empirical question how people will actually react to knowledge about this. Another reaction is to say, if these crazy scientists are so concerned about putting CO2 in the atmosphere, they want to think about these things, and that might actually mean we should be more serious about the risks of CO2 in the atmosphere. And by the way, it's not really a moral hazard, it's more like free riding on our grandkids. And by the way, it's not really a moral hazard, it's more like free riding on our grandkids.
Numerous air quality studies, including from CARB, California Air Quality Resource Board, have named submicron-sized particulates as being particularly harmful for human respiration. Through all the discussions today, I have not heard any mention of this fallout, and has this been studied, and also the effects of a highly reactive metal like aluminum on toxifying soils and waters?
The question is, what would be the effects of these materials on human health if they came down into the stratosphere, in particular small particles and aluminum?
So the collaborators of mine working on the aerosol scheme are actually folks from Carnegie Mellon who focused on human health impacts. And while we haven't published it, that was the very first thing we did, was do the order of magnitude calculation in level pencil and paper, but with an expert on human health impacts about whether there could be an issue. And for aluminum or other particles, there are a lot of toxicological things that need to get looked at seriously. But if you're just thinking about the sheer number of particles and the human health impact of small particles, the answer is, well, we haven't published it. That was the first thing we looked at with some of the leading experts who do epidemiological research on human health impacts, and it's not even close to being an issue.
To clarify, so 10 megatons of aluminum dumped into the atmosphere will have no human health impact.
So let me be more careful here. We're to separate out the toxicological. So the alumina, we've only begun to research and published nothing. Alumina, we've only begun to research and published nothing. We haven't done anything serious on alumina, and so there could be something terrible that we'll find tomorrow we haven't looked at it. We haven't done anything serious on alumina, and so there could be something terrible that we'll find tomorrow we haven't looked at it.
We don't do something about Alzheimer's in America, every single solitary hospital bed that exists in America, as the nurses can tell you, every single one will be occupied in the next 15 years with an Alzheimer's patient. Every